All right, so now I'm recording the session. Okay. All right, so I just wanted to review some of the concepts, and these are just brief concepts. It's not going to go in detail, but let's go ahead and see if we can answer any of these questions. All right. And it's kind of hard for me to see some things here. All right, there we go. Perfect. Okay, so first question we have here, what is the net for this figure? How could we draw the net for this figure? Okay. So when we're drawing a net, what might be a good idea is what's the base of this figure? Anyone know the name of the base of that figure?
Pentagon?
It is. Okay, you see how it has 5 sides? 1, 2, 3, 4, 5. Okay, so what we might want to do is start off by drawing a pentagon. Okay, so here's the base. And then what does each of these sides have?
Triangle.
Triangle.
You got it. So I'm going to draw triangles out from each side as best I can, right? And
Yes.
would that be the net for this figure?
Okay.
There it is. That would be number 1. Okay. Any questions on that one? And you see how we could fold up the sides now and you would get the exact same figure.
Yes.
Great. All right. So that's a review. I think that was from section 1, right?
Yes, sir.
Okay. All right. Let's take a look at number 2. So here's the figure that we're going to take a look at. And this is, by the way, we would call these 2 planes that intersect, right? And these 2 planes intersect at a
Line.
at a line. 2 planes intersect at a line. Correct. Okay. So number 2, it says, what are 2 other names for AB? So I'm guessing what it's saying is, what are 2 other names for line AB? I just don't think we see that. So here's line AB. How else could we name line AB?
Line BA.
Line BA, go in the reverse direction. We could do that. That's correct. And what's another way we could name it?
Line AC.
Yep, absolutely. Line AC.
Yeah, thank you.
You got it. Okay. And then, of course, we could do BC if we wanted to. So there's actually many ways we could name that way. So that looks good. All right, let's take a look at number 3. So let's name 2 opposite rays. So we just need to just name 2 of them. There's a couple of them in here. Well, actually, it is only 2 of them. So here's one opposite. Here's one ray. I'm going to name ray BA. What would be an opposite ray to BA?
BC.
Correct, BC. Okay, notice how we name rays. So we always start at the initial point, and then we go towards the terminal point. So it starts at the B, that's our initial point, and goes towards the terminal side. So these are 2 opposite rays. All right, number 4, what is the intersection of these 2 planes? We already said that they intersect at the line, so what would you call the intersection?
RQ.
Yep, and more specifically, we just say line RQ, and we put a little line on top, and that's it. So you guys are acing this little quiz if I gave you a little quiz on this. All right, number 5. So here's the new figure. The point on CF, we're going to name the point on CF that is 1 unit from F. So what's a point on CF that is 1 unit from F?
E.
That is E. Do we see that, Ratara?
Yes, sir.
Okay, so it's the line segment CF, so we're only talking about that cutoff point. So we can't talk about G. Even though G is also 1 unit from F, we've cut it. So it's not there anymore. All right, number 6. So 2 points that are 3 units from E. What are 2 points that are 3 units from E?
Is it point B and H?
Okay, so let's check the other one. 1, 2, 3, and H. You got it. So we can, remember, we can go either direction for distance, right or left. Awesome. Okay, number 7. What is the coordinate of the midpoint for AG?
It's D.
It's point D, and then what would the coordinate be?
-2.
-2. You got it. See that, Tara?
No.
Okay, so we have AG. It's from -5 to 1. So it's a total length of 1, 2, 3, 4, 5, 6 units, right?
Yes.
So what's halfway of 6?
What do you say, please?
What's half of 6?
3.
3. So what we would do is count 3 units from A now. 1, 2, 3. And where do we end up?
-2.
At -2. And that's why that's the midpoint.
Yeah.
There you go.
Okay.
Great. Okay, so let's go ahead and now let's do angles. So here's the figure. We have this angle. Let's do number 8. Okay. What are 2 other names for angle 1? So how could we call angle 1 by another name? Let me do, Watara, how about you first? Give me one name for angle 1.
My name into EC.
Close. We need one more letter to be more specific.
Oh, ECF.
That is correct. So angle ECF, perfect. Okay, Gigi, give me an angle.
Angle FC.
Angle FCE. Okay, perfect. And just to make a point, remember the vertex of the angle always needs to be in the middle. Absolutely. Great. Number 9. Okay, so if angle DCF is 90 degrees, and angle DCF is 90 degrees, and angle DCE is 3x plus 2, and angle FCE is 4x plus 1, what is the value of x? All right, so a good idea for number 9, and this is a pretty easy problem, but this is what we should get in the habit of always doing. We should draw a picture. So we have E, we have C, and we have F, and then we have D up here. So we should label our picture as much as possible. So here they tell us DCE. I'm sorry.
Are we at number 9 or 10?
I'm doing number 10, but I messed up, didn't I? That shouldn't be F, that should be D. Okay, so this should be D. All right, so DCE is 3x plus 2, so this is 3x plus 12. And then FCE is 4x plus 1, right? So how do we set up an equation to solve for x?
You add them together.
Okay, so we have 3x plus 12 plus 4x plus 1, and what's that supposed to equal? Any ideas? How about 90 degrees? Yeah. So what's this, the illustration of? Does anyone remember the theorem or the postulate that this describes?
I don't understand.
Okay, so in our textbooks, there's a reason why I can add these 2 parts of the angle and make it equal the whole. So this is a part plus another part equals the entire angle. Does anyone remember the name of the postulate or theorem of what allows me to do that? Probably not. Okay, this is called the angle addition postulate. Okay, now in geometry, it's important to remember some of these names of postulates and theorems. And do we know why?
No.
Okay, very shortly, I'm going to ask you to do something called proofs. So you're going to have to prove things. And in order to do a proof, you have to justify each step of the proof. So when you justify, you have to give a reason. So this would be a reason of why you do this. So I'm trying to get you used to that, and you'll see that as we go on in the course. All right, so let's go ahead and do this. Let's simplify this equation. What's 3x plus 4x?
7x.
7x. What's 12 plus 1?
13.
13 equals 90. Okay, so next step in the equation.
Subtract 13.
Okay, and we get 7x equals, can someone do that for me? 90 minus 13?
77.
77 looks good. Yep. Divide both.
77. Yeah.
Good. And then what's x? 11. You got 2 fingers.
11.
Yeah, yes.
Yeah.
Okay, now does that answer my question? We found the value of x. We are done. There you go. Okay, so number 10. Oh, that is number 10.
Yeah, that's number 10. We missed number 9.
Oh, so we'll change this. This is number 10. Let's go back and make this number 9. Okay, what does number 9 say? DCF is 9. DCF is 90. What's the measure of DCE? If DCF is 90 degrees, what's the measure of DCE? Do we know?
I think 45.
Okay, good guess. So it's a guess. It's 45. Why did you guess that, Ratara?
Because I just divide by 2.
Yeah. Now,
So-
we can do that if we know that CE is what? So this is
45.
correct. Correct if. This is a big if. Ray CE was what? There's a special name for CE. What would it have to be called?
Oh, I know that in Chinese.
Yeah, it's called the angle bisector. So if the problem told me that CE was an angle bisector, you would be 100% correct. Other than that, do we have any information for number 9? So I can't solve it. So guess what? I say I don't know. There's not enough information. So I would say not enough information.
I
Right.
hope we can say that like on every question we have.
Well, I hope not. But so in number 9,
Yeah.
they give us the entire angle is 90 degrees. We don't
Yes.
know what we don't know what CE is. It doesn't tell us what CE is. It doesn't mark that both of these angles are equal, does it?
No.
No. So we can't assume that both of them are equal. And it doesn't tell us that this is an angle bisector. So a bisector would then make them both equal. So since it doesn't tell us, so it doesn't tell us 2 things. It doesn't tell us it's an angle bisector. So no, we don't know that. That's bad. Or 2, it doesn't tell us we have congruent angles. So without both of those, we have not enough information. We can't solve this problem. So that sometimes happens in geometry class.
Okay.
Okay, so that's
So
it.
I think it's a tricky question.
It is. It is a
Yeah.
tricky question, yes. Okay. Now, look at 11. What if we know DCE and ECF are vertical complement, or are they vertical, complementary, or supplementary if I know that DCF equals 90? So here's what the question's asking. If you know the entire angle adds up to be 90 degrees, what must the 2 smaller angles be? What's this vocabulary word for that? If the sum of 2 angles equals 90, what do we call those angles? Complementary. Now, if they added to be 180 degrees, what would we call the angles?
Supplementary.
Supplementary. Yep. Okay, so those would be the different terms. Okay. Number 12. So why do we use one arrowhead when we draw a ray, such as ray GM? So in number 12, this is evidently supposed to look like this. Why is it only one arrowhead when I name a ray?
Because it's pointed at one direction.
Right. So a ray has a starting point and it goes on forever in only one direction. Perfect. So that's what I would write. And then 13. So if your classmate says angle GHI and angle XHY are not congruent because they are not adjacent angles, the measure of each is 87, what is your classmate's error? Okay, your classmate says two angles are not congruent because they are not adjacent. The measure of each is 87. What is your classmate's error? Can two angles be congruent even though they're not adjacent?
Yeah.
Yes. So your classmate's error is stating that only adjacent angles can be congruent, but there are other angles that can be congruent as well. Okay. So that was the first kind of little pop quiz, and that covered the first 5 sections. Okay. Are we feeling pretty confident with that?
Yeah.
Yes, a little
Good.
bit.
A little bit? Okay. Well, we can review that. All right, let's take a look at this other one. So now, did you guys, I don't know if you noticed this, Ratara, but if you notice 1-6, I did not put homework up there for it. Okay, and that's because 1-6 is about making constructions, okay?
Okay.
So if I was doing this in a real life class, I would actually ask you to do a few things. So this says construct a segment that's congruent to AF. So does anyone know how I would construct a segment that's congruent to AF if I was doing this with paper and pencil?
You fold it.
You could fold it, yeah. But here would be one way. So if we were reading the chapter, so this is the next question here. Here is the segment AF. And if I wanted to make a congruent segment, what I would do is get something called a compass. So a compass kind of looks like this, and it has a little pointy end, right? And has a wheel. And what you would do is you would put one end here, and you would measure it up to here, okay? Then what you would do is you would put it out here, and you would draw an arc. And then you would connect the dots of the arc, and then right there is how you would draw a congruent segment. Okay?
Okay.
Number 2, it says construct a perpendicular bisector. So this one's a tricky one. If I was asking you to do this by hand, watch this. So here's A and here's F. Okay. So what we would do for the perpendicular bisector, okay, let me see if I can remember this one. Okay, so we have to put the same protractor. We start the protractor off here, and we extend it a little bit more than halfway, and we draw an arc. Okay?
Okay.
We do the same thing over here. We don't do the same arc. We draw a little bit halfway. Okay? Using the same distance, we draw an arc up here. We draw an arc up here. We draw an arc down here. We draw an arc down here using this. And then what we do is we connect the intersections. And when we connect the intersections, what's going to end up happening is this becomes my perpendicular bisector. So we use a protractor. We go more than halfway. We find these points, and then we go more than, and then we just draw intersection arcs, and we connect the dots. And that's how we would do this by hand. I'm going to show you how to do this on a computer in a second. And then number 3, if I had an angle, here's an angle. And then we do the same thing. We would draw 2 arcs. And then we would draw another arc out here from the same spot, draw an arc. We draw another arc out here, see where it intersect. And we would connect the intersection points. And that would create 2 congruent angles. Okay. Did you guys download the program called GeoGebra yet?
Yeah, I did it.
Okay, good. So if you haven't, I would recommend doing that. So let's go ahead and see if I can do that now. GeoGebra. So this is at www.geogebra.com. And this is a really neat software program that lets you do some geometry stuff. So what I would do is I would actually download this if you can. Okay. And then I would go to GeoGebra Classic, and I'm going to download the Mac version right now just to show you how to do it. Okay. So this is all fantastic. Open the App Store. Okay. All right, there it is, GeoGebra. I'm going to install the app. Oh, this is going to take forever. So anyways, while that's downloading, let's go ahead and do another problem, and then I'll show you how to do some other things. Okay, so we're going to do constructions in a minute. All right, so let's go ahead and let's take a look at number 4. Okay, so number 4 says we have 2 endpoints. We have D is the endpoint -1, 8, and we have the G, which is the endpoint 3, 4. What is the midpoint of this segment? Does anyone remember how to find midpoint? It's going to be the sum of the x coordinates divided by 2, and then it's going to be the sum of the y coordinates.
Divided by 2.
Yeah.
Yeah.
Okay, so we're going to plug those in. So we have -1 plus 3 divided by 2, and then we have 8 plus 4 divided by 2. So we have the midpoint is going to be 2 over 2, comma, 12 over 2, and that's going to give me 1, comma, 6. So that's how you find the midpoint.
Yes.
Okay. So why don't you guys have paper now in front of you? Try to find the midpoint for number 5. Okay, so we have the midpoints, the endpoints F of -2, comma, 3, and we have G, which is going to be 1, comma, 1, and let's find the midpoint.
So,
All right, so we have an answer for the midpoint.
yes, so
I got -1 over 2, comma 2.
yeah, me too. I got -1 over 2 and 0.2.
And you got 2?
Yes.
Yep, great. That's correct. And that's usually how I like to write the answers too. I like fractions when possible, You know, so that's good. All right, let's try number 6. So number 6 asks about the distance between 2 points. So we have the point L, which is 8, 9, and we have the point Z, which is negative 10, 0. Does anyone recall the formula for the distance?
Yes.
Okay, who wants to give it to me?
I can take
Yeah, you want to, how about?
square root,
Uh-huh,
and we have x1, no,
okay,
x2,
uh-huh,
x2 plus x1, minus 1, minus x1,
uh-huh.
yeah, square root, I don't know how to call it, but square, yes,
It's squared.
squared, yes,
Yep, uh-huh,
and plus
uh-huh.
uh, y2 minus y1
Great,
squared,
squared, perfect. Excellent.
yes.
So let's plug these in now. And it doesn't matter the order as long as we're consistent, but let's call this the second point. So this is the second point, and this is our first point. So when we substitute these values in, we're going to get negative 10 minus 8 squared plus 0 minus 9 squared. So we have d equals the square root. And that's going to be negative 10 minus 8, right? So that's negative 18 squared plus negative 9.
Squared.
Okay, so negative 18 squared, what's that going to give us?
Negative what?
Negative 18 quantity squared.
I don't have a calculator right now.
That's a big number.
Yeah, let me calculate.
Okay. So I'm going to pull up my calculator. Okay. So I have okay, what do we got here? It's just taking a second here to load.
The square root of 405.
That's the final answer? Yep. Okay. Okay, now for this class, now if this is an algebra class, I would ask you to simplify the radical. But here we're just going to hit the square root of 405. For some reason, my calculator is not working. I don't know why. Okay. And then what's their calculator say when you hit the square root button?
Mine doesn't have a square root.
Okay, so turn your phone sideways. And you should have a square root button.
Oh, yeah.
And then you should be able to do that. And then we should get approximately
20.1.
20.1. And that looks good. And are we giving units?
No.
No. So that's our answer. Great. All right, let's look at number 7. So number 7 says, what's the perimeter of and the area of a square with side length of 11? So here's a picture of a square and has a side length of 11. So that means 11 on all sides. All right.
Okay.
So what's the formula for the perimeter of a square? Does anyone recall that?
Yeah. I don't know in English. I know
Sure.
in French. So.
So basically, it's going to be the sum of all the sides, right? So in English,
yes.
4 times a side length. That's what we would say. So the perimeter is going to be 4 times 11, which is going to give us 44. And what's our units?
No units.
No units. So we would just say units or U. Okay. And then the area of a square, area equals side squared. So area equals the 11 squared. And then when I do that in the calculator, I get 121. And then the U squared. So that's U for units. And those are going to be both of my answers. Okay, number 8, it asks for the circumference and area of a circle with radius r equals, so here's a circle, here's my radius, and it has r 7 inches. Ooh, now we have units. So circumference is 2 times pi times r. So circumference is going to be 2 times pi times 7, which equals 14 pi. And then we can use a calculator at this point and get an approximation. So does someone want to do that? We might need a big calculator here.
I can just type 3.14.
That should work.
43.98.
43.98, and we want inches.
96.
96. Okay, good. 96, and that looks good. All right, now the area of a circle is pi r squared. So area equals pi times 7 squared. So we're going to get 49 pi, and again, we can approximate that. For some reason, my calculator.
153.86.
86. And then this one's going to be inches squared for area. Okay. And that's about it. Let me see if my construction's downloaded. App Store, let's see that. Okay, let's see if I have, let's find the App Store. Oh, there it is, GeoGebra. Okay. So let's go ahead, and I just want to show you a couple quick constructions, because you can actually do these instead of by hand and turn these into the assignment. So we'll sign into GeoGebra. Okay. Sign in with Google. All right, let me type in. Okay, so here we go. All right, fantastic. So what we're going to do is go ahead, and I'm going to, let me see if I can do some things here. Let's view, and I'm going to view, not have the algebra up. Spreadsheet cast, let's just do, so we can, I'm not seeing how I can get off of this background. Take that off, okay. Input bar is good. Let's see what's layout. Maybe I could change this back. So I kind of want to get off the grid because I don't really need the grid. Here's the grid. Show grid. Oh, there we go. Done. Okay, so I just took off the grid. And I could probably take off the exit. So let me do that too. So there we go. And then preferences. Show x-axis, take that off, show y-axis. So I just took off the axes. Okay, so we're going to do two things. We're going to construct a line segment. So if I want to construct a line segment, I just pick the line segment tool. I drop a dash, I drop another dash, and there I go. Now, I can label points by giving it a name, and I can label another point by giving it another name. And there we go. There's my segment AB. Okay, now watch this. I can also now select that, and I can control copy, and I can control paste, and then guess what? I've now created a copy. So if I ask you on a question, copy the segment. I've now copied the segment. Okay, so let me delete that. Now, the other question that we had was we wanted to construct a perpendicular bisector, right? So watch this. If I selected this object, I can go to here, perpendicular line. I can do construct a perpendicular line here. Or, okay, so what actually do we want to do here? Control Z, undo here. We want to construct, oh, we've got someone new coming in. Okay. So we want to select this line, and we want to do it through the midpoint. So let me Control C. So construct the midpoint. Okay. Select this line, and let's see if we can find midpoint. Midpoint of that line. There it is. So what we're going to do now is select this line and this midpoint and construct a perpendicular line through it. And there we go. So now what we've just done is created the perpendicular bisector. Now, what does this perpendicular bisector have to be? It has to go through the segments, right? Could we measure this? So I could select the two dots, and I could measure. I think someone is got their I'm not seeing a measurement from here. Okay, so I think we want to go mute. Okay, is that better? Okay, I muted everybody. Okay, so here is the line, and we're going to try to, I want to try to measure this segment. Okay, so I want to see if I can figure out how I do this. I'm not seeing how to find measurement. Distance or length, bingo. Here to here, and there's my distance. So here's the distance from A to C. Now, what should my distance from C to B be if this is my perpendicular bisector? Gigi, what's the distance?
2.27.
It should also be that. So let's go ahead and try that. All right, so I'm going to go ahead and now measure distance or length again. And I'm going to check C to B, and I get, oh, look at that, 2.27. Now, what else does this have to be? It has to be perpendicular, doesn't it? So let's check the angle. So I need to put a point on this line someplace. Here's a point. And now watch this. I'm going to measure an angle. So I click the three dots, and let's see, what should this angle be? That's 270. The converse should be, let's try this again. So Control Z. So let's measure the angle going this direction. 90 degrees. There it is. So this is the perpendicular bisector. So if I ask you a question on a test or quiz, what you can actually do at this point is file, export this, and you can make it a picture, or you can make it, save it to your clipboard, and you can paste it in to your homework file. Does that make sense? Okay. So anytime on your homework that I ask you to draw anything, you can use this software, GeoGebra, and you can make a software. So let's try one more. The other one was the angle bisector, right? So let's draw an angle. Let's see if I can draw an angle. Okay, oops. Okay, here's an angle. So angle is drawn with 3 points. So there we go. Or not. Let's just delete that. Okay, so let's draw. How about we draw array. There we go. So there's our angle, and we can label that angle with the different points. Edit, undo, Control C. Okay, there's an angle. We'll call that an angle. And we'll call this an angle. All right. Now let's go ahead and let's find the angle bisector. So what we can do now is angle bisector of these points. And there's your angle bisector. Got it?
Yeah.
Okay. So those were those problems. And look at this, it's about 7 o'clock. So we are 8 o'clock your time, and we're about done with this lesson for today. So let me stop my share screen, and let me come back. And it looks like someone joined. Who joined? We have Gigi here, we have Ratara, and who is the other person who came to class? I don't know. This is user. Okay, so what I'm going to do is I'm going to stop recording this session, and then I'm going to post the recording on the website. This way, if you want to refer back to any notes we did, that's what you should have. So just a reminder, at this point, you really should have sections 1.1, 1.2, 1.3, 1.4, and 1.5 homeworks completed. So if you haven't done that, that's what I would be working on. And then tomorrow, you should be finishing up all chapter 1, and you should get started on chapter 2. And then I want to schedule another session Thursday our time in America, and in China, it's going to be on Friday, right? You're 12 hours ahead?
Yeah. If it's morning, then no. If it's evening, then it should be 15. But
It's going to be our nighttime on Thursday for this week only. So it's going to be your morning.
okay.
So it should be Friday morning.
Yeah.
So I'll schedule another meeting this Thursday at 7 p.m. Eastern Standard Time.
Okay.
Okay? And then that would be the same as 7 a.m. on Friday morning in China.
Mm-hmm. Can you also send a calendar thing? Because, yeah, it automatically changed to my time.
Yeah, wasn't that neat? That was pretty cool. Yeah, it should automatically change to your time. And I'll do that for each meeting. I'll send an invite so you remember when it is. And then I always record these videos. And then, again, and I was talking to Gigi or Tara about this earlier. If you guys have any difficulties or problems with the course as you're working through it, you can always send me an email. And if we need to set up another session, I can do that. We can have more office hours if you need more office hours. And then hopefully, and I'll try to communicate. I'll send some emails to you. So if you're forgetting to do an assignment, I'll try to send you assignment notes to get those in. And if I see you're struggling on a homework assignment, and I'll just send you a note to see if you need any help on them. Okay? So I want this to be as beneficial as possible and you learn as much as possible, but I do know that we don't have a lot of time. So I'm trying not to give you too much work. So it's a very minimal amount of work, but hopefully we can keep up with it, okay?
Okay, so.
Okay. Any questions?
I'm good.
Okay, great.
No.
Sounds good. So keep working on it. If you've been, and then I'm going to post more videos for chapter 3 for next week as soon as possible. And so I'm going to stop recording so I can post this video, and have a great night.
Thank you, you too.
Thank you.
Thank you.